So another useful feature of curves is symmetry. If you notice symmetry about a curve, then really you only have to draw half the curve and then copy it. Odd functions, just like we have odd numbers, we have odd functions as well. And the formal definition is function negative x is equal to the negative of function x. Again, if you see the picture, it's easier to tell because you should see rotational symmetry, 180 degree rotational symmetry, which is also known as point symmetry about the origin. Okay, so spin it 180 degrees, it looks the same. So over on the wall there, we've got a couple of classic shapes. Which ones could be classified as odd functions? Cubic, yep, spin that 180 degrees, we'll get the same shape. Hyperbola, yep, spin that 180 degrees, you get the same shape. No, I knew I'd catch you out on that one. Not the circle, why not? Because it's not a function. In order to be an odd function, it has to be a function. Okay, so x cubed would be, 1 on x would be x to the 7 minus x to the 5. If we're talking about polynomials, if the powers are all odd, it's going to be an odd function. Okay? So all the powers are odd, we've got an odd function. So if we had to prove it though, it's not enough to say, oh look, the powers are odds, therefore it's an odd function. Okay? We can tell it by looking at it, but if we have to formally prove it, we've got to come back to the definition. So function x is x cubed plus x to the 7. Function negative x, everywhere I see an x, replace it with negative x. Well, if I raise a negative number to an odd power, it's going to be negative. So I have minus x cubed minus x to the 7. I can factorise the negative out, and now I have negative function x, thus proving it is an odd function. So if they actually ask you to prove, it always comes back to the definition. You've got to formally prove it using that definition, so therefore odd. Well, we also have even functions, which also have symmetry. Function negative x is equal to function x, and that has line symmetry. Okay? So the y-axis is an axis of symmetry. So the parabola is the classic one. I mean, if we fold it on top of itself, we would have an even function. Now, hang on, oh, here's a question for you, so you've just walked in. Even function is any function that when you fold it on top of itself, you get the same shape, yeah? Y-axis is an axis of symmetry. I've got 4 shapes on the wall there. Which ones would be even functions? Which one has that line symmetry? Oh, bad luck. Oh. Well, unfortunately, so I knew I'd get you because I got a lot of other people when we talked about odd functions. Circle is not a function, therefore it can't be an even function. Okay. So, y equals x squared. Y equals x squared plus 4. So again, you see a similar thing with polynomials. If all the powers are even, it's going to be an even function. We think of 0 as an even number for the sake of this, so the constant here is like 4x to the power of 0. So let's prove y equals x squared plus 4. So same idea. Let's have a look at what function negative x does. This time, you raise a negative number to an even power, you're going to get a positive number. So we get x squared plus 4, which is indeed function x. Therefore, yes, it's an even function. Okay, so that's an idea, as I say, that can help us when we're graphing. If we notice it has symmetry